Alrighty, so the first integral of the day is going to be the integral of x cubed times 1 minus x squared under a square root with respect to x dx. The first thing that I'm seeing is that I could use a substitution, although it would make my life harder. I could use u equal to 3x squared. I have an x squared here, but that would put a du under the radical, which just makes my life 20 times harder. So instead, I'm going to swap out x with sine. I'm going to give sine the variable t, and the derivative of sine to account for our dx in that integral is going to be cosine t dt. This transformation will change our integral into sine cubed t times the square root of 1 minus sine squared t times cosine t dt, because we have to account for that dx that we just substituted. The next thing that I see is I have a 1 minus sine squared t. 1 minus sine squared t is the equivalent of cosine squared t. The opposite is also true. When you have sine squared t, it would be 1 minus cosine squared t. We don't have that, but just in case you need that, that's the two conversions that you can change your variables into. So I'm going to go ahead and rewrite this integral now as sine cubed t square root of cosine squared t cosine t dt. Now we have a square root with something squared under it. Those cancel each other out. Now we have sine cubed t cosine t dt. We have two cosines, which means it's going to be integral sine cubed t cosine squared dt. There should be a t in there. Okay, now we have something that we can actually work with, but we're still not close to done. So what we're going to do is we're going to look at our sine cubed t and our cosine squared t dt. The only problem with this integral is that sine is an odd power. So we're going to use our trig to split sine into sine squared t and sine t. That's basically the same thing. It's just split into 2 times cosine squared dt, t dt. Now you remember that we said earlier that sine squared t is the same as 1 minus cosine squared t. Now we're going to use that here to simplify that sine squared and make it in terms of cosine so that we can make a U-substitution. So we're going to do that. And we don't want to change our cosine squared because cosine is going to be the one we're going to use for our u. So if we were to use u as cosine t, our du would be negative sine t dt. And for the sake of simplification, we have two substitutions now where x is equal to sine and u is equal to cosine. Knowing that we'll have to sub back in twice, I'm going to say our du is just equal to arcsine t. And you'll see why in a minute. Now we can rewrite our integral 1 minus cosine squared t sine t times cosine squared t dt in terms of u. So it's going to be 1 minus u squared times u squared du. I'm just going to quickly rewrite this so that I can visualize this better. And this, we have a u squared times on the outside of the parentheses that we have to distribute. So this is going to transform our integral once again into negative u squared plus u to the fourth du. Now solving the actual integral itself is going to be negative u cubed over 3 plus u to the fifth over 5 plus c. We're not done. All we have to do now is turn this back into terms of x. So what we do for that is we take our answer that we have in terms of u and convert it back into what we originally had in terms of x. So we need to change our u, then we need to change our t. We're going to change our u first, and then we're going to change our t. So I'm just going to do it all at once. It'll be negative 1/3. I'm pulling out the negative 1/3 and then 1/5 out of both fractions to make my final answer a little cleaner. So negative 1/3 cosine cubed. And remember, we set that back into arcsine of x. Since it's arcsine of t, t is equal to x plus 1/5 cosine to the fifth arcsine x plus c, and that's our final answer.